Technically speaking, technically speaking, I ain't talking vegan when I said that I've been eating, making money on the side, but I use it for the main. I'm speaking in code when I tech talk that financial freedom. Have a seat cause you gon' wanna sit up at my table, yeah. Plugged in that it, girl, IT with the cables, yeah. Network engineering is for you, it ain't no labels, yeah. Shaky with my passion, took a leap, it got me stable, yeah. Now I make 100K or better, paper couldn't fit a stapler, and I spend it on my passion cause I'm capable. Technically speaking, now I'm really talking vegan when I said that I've been eating, I've been technically speaking. Technically speaking, China white.
Welcome to Technically Speaking, where we help you increase your income through tech. Today, we will be discussing common network ports and services. This is a key element of the Network Plus exam. Completing this lesson will bring you one step closer to passing with confidence and unlocking new opportunities in the tech world. For more resources to help you succeed, check the description for the links to our exam prep notes, courses, and personalized consultation services. If this video helps you, don't forget to like and subscribe for more ways to boost your tech skills and income. Just a quick introduction to the ones that are new here. My name is Jessica. You can call me Jess, and I am the founder of Technically Speaking. I came from a customer service and a food service worker background, and I broke into tech in 2020 as my first job was a voice network engineer, and it gave me the financial stability I needed. Then I thought, wow, if people could learn tech, they would be able to better their financial situation as well. So here I am. My mission for this lesson is to simplify tech concepts and empower you to succeed. The goal of this exam topic is for you to confidently explain networking ports, protocols, and services. We'll also explore different traffic types and how they function in a network. This will not only help you with passing the exam, but also aid in your interviewing and troubleshooting skills. File transfer and secure communication protocols. FTP uses port 20 and 21. File transfer protocol, FTP, is a standard protocol used for transferring files between computers on a network. However, FTP is not encrypted, making it vulnerable to interception and attacks. It is mostly used in environments where security isn't a concern or for internal networks. SFTP and SSH uses port 22. Secure File Transfer Protocol, SFTP, and Secure Shell, SSH, use port 22 to provide encrypted file transfers and remote access to devices. Unlike FTP, SFTP ensures that data being transferred is protected, making it suitable for sensitive information. SSH provides secure remote command line access to servers and other networking devices, making the preferred choice over insecure protocols like Telnet. Telnet allows remote access to devices using port 23, but it transmits data, including login credentials, in plain text, making it highly insecure. Telnet has been largely replaced by SSH for secure remote access. Now, when transferring files or accessing devices remotely, using secure protocols like SFTP or SSH is essential for protecting sensitive data, as opposed to using insecure options like FTP or Telnet. Let's talk about email and directory services. SMTP, port 25. Simple Mail Transfer Protocol, SMTP, is the standard protocol used for sending emails between mail servers and from email clients to servers. However, SMTP does not provide encryption, which means that emails sent over port 25 are transmitted in plain text, making it vulnerable to interception. Lightweight Directory Access Protocol over SSL, LDAPS, or what we call LDAPs, Provide secure, encrypted access to directory service, such as Microsoft Active Directory. It ensures that sensitive information, such as user credentials and organizational data, is protected as it is transmitted between clients and directory servers. SMTPS uses port 587. SMTPS is a secure version of SMTP, using port 587 with TLS and SSL encryption to ensure that emails are securely transmitted over the internet. This adds a layer of security by encrypting the content of the email during transmission, protecting it from being intercepted or tampered with. The key point here is email protocols like SMTP and SMTPS are essential for sending emails, but it's important to use encrypted versions such as SMTPS to protect against sensitive information. LDAPs is critical for secure access to directory service, especially dealing with sensitive organizational data. Web traffic protocols. Hypertext Transfer Protocol, HTTP, is the standard protocol used for transferring web pages and other content over the internet. HTTP traffic sent over port 80 is unencrypted, meaning that any data transmitted between the user and the server, including login credentials or personal information, can be intercepted or viewed by malicious actors. Hypertext Transfer Protocol Secure, HTTPS, is the secure version of HTTP and operates over port 443. HTTPS uses TLS and SSL encryption to ensure that data transmitted between the web browser and the server is secure. This protects sensitive information like credit card details, personal data, or login credentials from being intercepted or tampered with at any point. The whole key point here is HTTPS is now the standard for secure web communication, and most websites should use it to protect their data and users' data. HTTP is still used in some cases, but is generally considered unsafe for handling sensitive information. Always prioritize HTTPS for web traffic security. DNS and Network Services Protocol. Domain Name System, DNS, translate domain names like www.google.com into IP addresses that computers can use to identify one another over the internet. This process happens over port 53, enabling users to access websites and servers by using human readable names instead of remembering complex IP addresses. Dynamic Host Configuration Protocol, DHCP, automatically assigns IP addresses and other network configuration details like DNS server, default gateway, etc., to devices on a network. This process ensures that each device has a unique IP address without requiring manual configuration, facilitating easy connectivity for all devices. Network Time Protocol, NTP, is responsible for ensuring that all devices on a network have synchronized time. Using port 123, NTP ensures that servers, routers, and devices have accurate clocks, which is critical for tasks such as logging events, authentication, and ensuring network security. DNS, DHCP, and NTP are essential protocols for keeping network operations running smoothly. DNS translates domain names into IPs, DHCP automates IP address assignments, and NTP ensures time synchronization across devices. File sharing and logging protocols. Server message block, SMB, is a protocol used for file and printer sharing between devices on a network. Operating over Port 445, SMB allows users to access files and printers that are shared on a remote device as if they were locally connected. This protocol is commonly used in Windows-based networks, but is also compatible with other operating systems. Syslog is a standard protocol for collecting and managing log messages from different devices, such as routers, switches, or even servers, and firewalls. Using port 514, Syslog centralizes logging data, which is crucial for monitoring network activity, troubleshooting, and identifying security issues. It helps networks administrators track and analyze events across the network. SMB is vital for enabling file and printer sharing across a network, while Syslog provides a standardized way to collect and analyze logs from multiple devices, making it easier to manage and secure network environments. Additional network protocols. Remote Desktop Protocol, RDP, is used to remotely access and control Windows machine from another device. Operating over port 3389, RDP allows users to view and interact with the desktop environment of the remote machine as if they were just sitting right in front of you. This is widely used in IT management, troubleshooting, and remote work. Structured Query Language, SQL. This is a language used to communicate with and manage SQL databases. Through port 1433, SQL servers and applications can exchange data, execute queries, and perform database operations. SQL is critical in managing databases for applications that require large-scale data storage and retrieval. Session Initiation Protocol, SIP, is a communication protocol that enables the initiation, maintenance, and termination of voice and video calls over IP networks. SIP uses port 5060 for unencrypted communication and port 5061 for encrypted calls. It is a foundational protocol for VoIP, voice over IP systems, and modern communication applications like video conferencing. These additional protocols, RDP, SQL, and SIP, serve specific functions such as remote desktop access, database communication, and voice video call initiation. This makes them essential for both IT management and modern communication systems. Internet protocol types. Internet Control Message Protocol, ICMP, is primarily used for diagnostic and error reporting functions within a network. A common example is the ping command, which helps verify the availability of a network device and measures the response time between devices. ICMP is essential for troubleshooting and maintaining network performance. Transmission Control Protocol, TCP, is a connection-oriented protocol that ensures reliable and ordered delivery of data between devices. TCP breaks down into packets, establishes a connection, and ensures all packets are received and reassembled correctly. If used in applications where accuracy is critical, such as web browsing and email. User Datagram Protocol, UDP, is a connection-less protocol that allows for faster communication by not verifying the delivery of packets. It's just used in situations where speed is more important than reliability, such as streaming video, gaming, or real-time communication like voice or video calls. Generic Routing Encapsulation, GRE, is a tunneling protocol that enables different network protocols to transmit over IP networks. GRE is often used in VPNs to create tunnels that allow communication between different networks as if they were on the same local network. Internet Protocol Security, IPsec, is a suite of protocols used to secure IP communications by authenticating and encrypting each IP packet. It uses the authentication header, AH, and encapsulating security payload, the ESP, to provide data integrity, data authentication, and confidentiality. Internet Key Exchange, or IKE, is used to establish secure connections between devices. Understanding these IP protocol types, from ICMP for diagnostics, TCP UDP for communication, to GRE and IPsec for tunneling and security, this is critical to manage and secure network traffic. Traffic types. Unicast is the most common type of traffic where data is sent from one device to one specific destination. This is typical in applications such as web browsing or sending emails, where data is directed at a single recipient. Multicast allows data to be sent from one source to multiple specific recipients who have expressed interest in receiving the data. It's more efficient than unicast when delivering content to multiple users, as the data is only sent once and is replicated by network devices to reach all subscribers. Examples include streaming video or real-time updates in financial apps. Anycast allows data to be sent to multiple locations, but it is delivered to the nearest or the most optimal recipient based on network conditions. Anycast is often used in content delivery networks, CDNs, and DNS to direct users to the nearest server, improving speed and efficiency. Broadcast sends data from one source to all devices on the same network segment. This is commonly used in protocols such as DHCP to automatically assign IP addresses. Broadcast can generate a lot of network traffic, which is why they're typically restricted to local network segments, like within a lane. Each traffic type, unicast, multicast, anycast, and broadcast, serves different networking needs, from one-to-one communication to deliver that data, or to multiple recipients to deliver that data. And that's just to optimize data flow in different various scenarios. And that wraps up our lesson on common networking ports, protocols, services, and traffic types. We've covered key protocols like HTTP, FTP, DNS, and so many others that are foundational to network communication. You now have a better understanding of how traffic flows through a network, the different traffic types, and how protocols work to keep everything connected and secure. If you found this video helpful, don't forget to give it a thumbs up and hit the subscribe button to stay updated with more tech tutorials. And if you have any questions or need any clarification on the topics we discussed, drop a comment below. I love to help. Also, be sure to check the description for more resources and links to related topics. Thank you for watching, and I'll see you in the next video. Keep learning and keep exploring the world of tech.